Hello everyone, Ziyaan Sir this side. Let's start with a brief introduction. I have done MSc Zoology. I have qualified CSIR NET JRF with All India rank 65. One more exam that is called as State Maharashtra for the lectureship, and another exam that is called as PET for the PhD entrance test. Currently, I am doing my PhD in the SPPU Pune. Our today's topic is Mendel's laws of inheritance. So the first thing first, if I'll be dealing with the first thing, hopefully you do know, but still I can go for the first law of Mendel's inheritance is law of dominance. Here I've drawn two different parents. They are having different types of genotype and phenotype. The first parent I've drawn is having the genotype as capital T, whereas the other parent is having small t. And if I'll be going for the crossing of both of them, I will be having the result as capital T and the small t. So the capital T pure tall parent, there are two words you should be knowing about the genotype and the phenotype. This is the genotype of an organism, that is the genetic constituent, whereas this is the phenotype of that organism, which means the physical appearance. So if I am having capital T and the capital T, the organism has to be tall, and if I am having small t and the small t, the organism will be dwarf. But what if I will be going for the first generation, that is the gamete formation of this capital T and the small t? Both of them are crossing together and they are forming capital T and the small t. But still, do remember one thing: if the capital and the small letters are coming together, the capital will suppress the small. Here the same has happened, and the capital T has expressed itself, making all plants as tall. This is the first law of inheritance of Mendel, that is called as the law of dominance. Now, if I will be dealing with the second law, that is nothing but just the continuation of the law of dominance, that is called as the law of segregation. Again, what we had in the last cross, we had capital T and the small t here. So what I did, I've just crossed the capital T and the small t again, like the another individual with the same genotypic characters. We call it as reciprocal cross. Do remember one thing, this is what I've made, it's called as Punnett square. Please deal with all the gametes which are on the horizontal line. Always please remember, if you are preparing for a competitive exam, all the gametes which are on the horizontal line are male gametes, and the gametes which are here on the vertical line are the female. So if I'll be just going for a simple cross here, like the capital T and the capital T will be making tall. Another capital T and the small t you are having again tall. The third is again capital T and the small t, but the last one is not having like the capital T and the small t, rather it's having small t and the small t. So if I'll be checking them out, I'm having 3 tall and 1 dwarf. So phenotypically I'm having 3 tall and 1 dwarf. Simple. Phenotypically I'm having 3 tall and 1 dwarf. But in case of the genotypic ratio, I'm having 1 tall pure, 2 tall hybrid, again 1 tall pure. This is the case of the phenotypic and genotypic ratio. Hopefully you are getting me. This is called as the second law of Mendel's inheritance. This is also called as law of segregation and the law of purity of gametes. Please deal with all the names. Now here the time has come that we should be dealing with the third one, called as the law of independent assortment. Here I'm just adjusting my screen. Okay, done. So what Mendel did, he used 2 characters at one time. He took capital R again along with capital Y and the capital Y. The phenotype for this was round yellow. The shape of the P was round and the color of the P was yellow. The other one was small r and the small y. Do remember one thing, that always the alphabet of the dominant gene is counted. So here you will be having small r for the wrinkled and small y for the green color. Again, this was referred as P for parent. And if you are making the haploid gamete, one single r from here, one single y from here, making a capital R and the capital Y. If you are making here, small r and the small y. If both of these gametes are fusing together and forming the first generation, what we call as F1, you will be having capital R small r and the capital Y small y. Do remember one thing, that the F1's full form is first filial generation. And one more thing, this F1 word was given by none other than Sir William Bateson. Now, here a word is written selfing. What does selfing means? Which means the same genotype of capital R small r capital Y and the small y is crossed again with capital R small r and the capital Y small y. So you are having this square. This square is called as Punnett square. As I have already told you that I'll be explaining this Punnett square in the handwritten format. So today like I'm completing that by saying. Here again I've drawn all the male characters on the horizontal line and all the female characters on the vertical line. This is like the different combinations which I'll be having from this, that is capital R, capital Y, capital R, small r, capital Y, small r, small y. And they'll all like 16 different results you will be having. So I've just like made them, all of them. So let's just solve them. What I did, I've just gone for, if I'm having one capital R and one capital Y, I'll be just dealing with a tick. So this is a tick. Again one capital R, yes, this is also a tick, this is a tick, yes, this as well, this one as well, this one as well, this one as well, this one as well, and this one as well. All of them are having like at least one capital R and at least one capital Y. The other I'll be dealing will be having like the capital R and the small y, double small y. So yes, what I have drawn there, a square. So yes, here a square, again here a square, and here as well I'm having a square. The last small r with a capital Y. I have to draw a circle there. Yes, one circle, two circle, and three circle. And the last one is small r, small y, small y. That is last one, is the cross. Now we have to count out them. How many ticks are there? So if you are checking just like how many ticks are there, there's a trick to remember. Do remember one thing, there's a triangle which is formed here. Just deal with. This is a triangle which is having at least one dominant in both the genes. This is what we call, I call it as a triangle of the Punnett square. If you will be counting them 1, 2, 3, 4, 5, 6, 7, 8, 9. So here you are having 9 round yellow. You are having 9 round yellow. Deal with. Now round green, which means you have to count the square. So the first square, the second square, and the third square. So you are having 3 round green. Now 3 up, you need to go for wrinkled yellow. So 1, 2, 3. Again 3 you are having, and the last but not the least one, it is for only one single. That is simply the wrinkled green. That is like what I will be going for, one only. So the phenotypic ratio of dihybrid cross is 9:2, 3:2, 3:1, whereas the genotypic ratio is very simple. Like hopefully you won't be able to call it as simple, but it's very simple. According to me, you just need to write 1, 2, 1, 2, 4, 2, 1, 2, 1. 1:2, 2:2, 1:2, 2:2, 4:2, 2:2, 1:2, 2:2, 1. Simply, it's very simple as compared to me. Hopefully this lecture is beneficial for you. Thank you very much.